Two small balls, each of mass m, are connected by a light rigid rod of length L. The system is suspended from its center by a thin wire of torsional constant K. The rod is rotated about the wire through an angle theta naught and released. Find the tension in the rod if the system passes through the mean position. Fine. Now let's say I'll draw the upper view of the system. Let's say this is the initial position of the two blocks or the two balls. They are rotated by an angle of theta naught. Fine. Now what will happen is the restoring force or the restoring torque will act on both of them. Now we know that torque acting on them will be given by k theta. So the work done by the torque will be given by k theta d theta, integrating it from 0 to theta naught. So it will be half of k theta naught square. Fine. Now this work done will be completely converted into the angular velocity of the two balls when the two balls will reach their mean position again. So this work done will be equal to the rotational energy of the two balls. Fine. And this rotational energy will be equal to half of I omega square. Fine. I can calculate the omega, I can calculate the value of moment of inertia of the two balls along the center of rotation about point O. So it can be written as m, that is the mass of the ball, into L by 2 whole square plus m L by 2 whole square. It comes out to be ml square by 4. So substituting this value in this equation, the work done, that is half of k theta naught square, will be equal to half of I, that is ml square by 4 into omega square. So this half gets cancelled. The omega square value comes out to be k theta naught square by 4 divided by ml square. Right. Now what I have to calculate is the tension in the rod. Now let's say when it is moving like this, an mg force will be downward. Centrifugal force, that is m omega square by L by 2, will be acting straight outward. So tension will be equal to the resultant of mg and the centrifugal force. So net tension will be given by mg whole square plus m omega square L by 2 whole square. Substituting the value of omega square over here, I have mg square plus m L by 2 into 4 k theta naught square by ml square, it's whole square to the power 1 by 2. So again the tension comes out to be k square theta naught to the power 4 by L square plus m square g square to the power 1 by 2. That is the answer.